Hello guys, let's start important points in organic chemistry and revision of organic chemistry. First of all, we are starting with nomenclature, common naming system. We all know the prefix form is used for one number of carbon. For example, if we have one carbon and aldehyde group HCHO, so then it is called formaldehyde, formic acid, formyl chloride, and amide group, formamide. Then acid is used for two number carbon. So that is if two number carbon is present in aldehyde, CH3CHO, acetaldehyde, acetic acid, acetyl chloride, COCl, and amide group is present in two carbon, so that is called acetamide. Then propione is used for three number carbon. So three number carbon aldehyde, that is propionaldehyde, propionic acid if carboxylic acid present. If three carbon are present in acid halide like CH3 CH2 COCl, then that is called propionyl halide, and propionamide if it is present in amide. So these all are common naming system. And four carbon are present, then common naming system is butyl. So suppose four carbon are present in aldehyde, then that is called butyraldehyde. Butyric acid means four carbon are present in carboxylic acid. If four carbon are present in acid halide, then butyryl aldehyde chloride, and butyramide, that four carbon are present in amide. Valor when is used when number of carbon are 5. So if 5 carbon are present, then common naming system is called valor. So valoraldehyde, that is if 5 number carbon present in valoraldehyde. Valeric acid, if carboxylic acid having 5 carbon, then that is called valeric acid. If 5 carbon are present in acid halide, then that is called valor chloride, like 1, 1, 2, 3, 4, 5, total 5 carbon are present. Then if in amide 5 carbon are present, then that is called valoramide. 1, 2, 3, 4, 5. If 3 carbon and 1 double bond is present, then that is called acryl in common naming system, like acryl aldehyde, like acryl aldehyde. Then acrylic acid, then acryl chloride, then acrylamide. So if 3 carbon are there and 1 double bond is there, then that is called acryl. Croton is used for 4 carbon plus 1 double bond. If 4 carbon are there and 1 double bond is there, then that is called croton. So crotonaldehyde, crotonic acid, and then crotonyl chloride, then crotonamide. You can understand what is the meaning of croton. And double bond should be at second position. Suppose here is 1 and 2, on second position there is double bond. 1 2, there is second position. 1 2, second position. 1 2. So 4 carbon plus 1 double bond, and double bond should be at second position, then that is called croton. Then for nitrile, form nitrile CN, isonitrile I, that is NC, so form isonitrile, methyl formate. Acid, again number of carbon are 2. Then acetonitrile, acetoisonitrile, methyl acetate. Propione is used for 3 carbon, that is the structure of propionitrile, propione, isonitrile, propionate, ester. Butyl for 4 carbon, that is cyanide, then that is called butronitrile, butyroisonitrile, and methyl and butyrate, that is for ester. Valor, when 5 carbon are present. So if in cyanide 5 carbon are present, then valeronitrile, isocyanide, valeroisonitrile, then methyl isovalerate. Again 3 carbon plus double bond, then that is called acryl. Acrylonitrile, acryloisonitrile, methyl acrylate. Proton 4 carbon are present, and At second position there should be double bond. So croton nitrile, croton isonitrile, and methyl crotonate, that is a ester. Secondary suffix of some functional group we all know. For carboxylic acid we have to use oic acid. For sulfonic acid SO3H group we have to use sulfonic acid. Then anhydride is alkanoic anhydride or oic anhydride. Then for ester we have used O8 like alkyl alkanoate, alkanoyl halide, OL halide. For acid halide. And for amide we have to use amide like amide. For nitrile we have to use CN we have to use nitrile. Then CHO aldehyde we have to use ALL. And the secondary suffix, that is on is used for alkanone. Alkanol alcohol, thiol, that is for SH. For NH2 we have to use amine. Prefix of these groups should also remember. For example, for CWH there is carboxy, SO3A, that is sulfo. These prefix are used when two functional group are present. When two functional group are present, then these suffix are very important. For amide we have to use carbamoyl. For cyanide we have to use cyano. That is for prefix. That is a basic nomenclature scheme. That is, first we have to apply secondary prefix, then primary prefix, then word root, then primary suffix, then secondary suffix. Now what is secondary suffix? Secondary suffix is the suffix secondary. First of all, secondary prefix. What is secondary prefix? That is a functional lower priority functional group, or methyl, ethyl, like that, or prefix of functional group. And primary prefix is generally used to distinguish between acyclic and cyclic compound. That is like cyclo is the primary prefix. Word root means number of carbon. Primary suffix are three: ane, ene, and ine. If single bond is present, then ane. If double bond is present, then ene. If triple bond is present, then ine. And secondary suffix we have to use, that is a suffix of proper functional group. For example, for alcohol we have to use ol. For amine we have to use amine. For amide we have to use amide. For carboxylic acid we are using oic acid. So these are called secondary suffix. Secondary suffix means suffix of functional group. So that is a part of IUPAC nomenclature. Points to remember in structural isomerism, that chain isomerism have characteristic. They have different sides of main chain or parent chain, and the condition is they have same nature of locant nature should be same, because if locant's nature should not same na, then they can be positional isomer. They have different position of locants, and but parent chain should be same. For functional isomer actually they have different nature of locant. Means functional isomer are those isomers in which functional group is different. So functional group is different, it means family is different. But all of you know that for any type of isomerism, molecular formula should be same. So if molecular formula is same but functional group is different, then they will become functional isomer. There are some pairs, family pairs, which form functional isomer. For example, aldehyde aldehyde and ketone. Aldehyde and ketone are functional isomer. Similarly, ether and alcohol are also functional isomer. Then carboxylic acid and ester, they are also functional isomers. Then 1 degree, 2 degree, and 3 degree amines, they are also functional isomers to each other. Then metamerism. In metamerism, there may be different nature of alkyl group along a polyvalent functional group. Means polyvalent functional group should be there. For example, ether, ROR dash. Now that O is working as a polyvalent group. If both R dash and R are different in two different compounds, then they will be metamers to each other. Then ester, R C double bond O O R dash. In ester, the polyvalent functional group is actually C double bond O. Then suppose for 2-degree amine, NH, R and R dash. So NH is working as a polyvalent functional group. So polyvalent functional group is should be present in metamerism. Aldehyde cannot show metamerism, alcohol cannot show metamerism, carboxylic acid cannot show metamerism. So metamerism also of two type, functional metamerism and positional metamerism, and then that one is position is different. Then chain metamerism, if chain of the alkyl group is different. For tautomerism like ketoenol tautomerism, that is the best example of tautomerism. Ketoenol, in one compound is in keto form and second one is in enol form. The two functional isomers remain in dynamic equilibrium to each other. Then you can write down the IUPAC name and you can how can you find out the degree of unsaturation. How we can identify some functional group? How can we identify some functional group? For example, alkane is there. So reagent for alkane is concentrate H2SO4, concentrate NaOH, KMnO4. Then no reaction will be there. Alkane will show no reaction, but alkene will show. Alkene can be identified using Bayer's reagent, or that is alkaline cold KMnO4. Pink color of Bayer's reagent will be disappear when alkene react with Bayer's reagent. Then alkene and alkyne all can be identified using bromine water also. They actually red color of bromine water will decolorize when it react with unsaturated compound like alkene and alkyne. Then terminal alkyne can be distinguished or can be identified using cuprous chloride plus NH4OH. Red precipitate will form, and AgNO3 and ammonium hydroxide when react with terminal alkyne. Terminal alkyne means simply the alkyne in which H is the triple bond is present on terminal position. So if terminal alkyne react with AgNO3 and ammonium hydroxide, there will be a white precipitate will form. 1-degree, 2-degree and 3-degree alcohol can be distinguished using Lucas reagent. Lucas reagent, especially in that 3-degree alcohol, when react with Lucas reagent, then turbidity will appears immediately. For second 2-degree alcohol, when react with Lucas reagent, then turbidity appears after 5 minutes. But when 1-degree alcohol react with Lucas reagent, then no turbidity at room temperature. Turbidity will be appear after heating, or turbidity will appear after 30 minutes. So it means it is 1-degree alcohol. So in this way we can identify different type of functional groups. Then there is enols like phenol. Phenol can be identified by reacting with neutral FeCl3 solution. Neutral FeCl3 react with phenol, then colored precipitate will appear. So like it may be blue, violet, green color. And carbonyl group, yes, carbonyl group may be of aldehyde or ketone. It can be identified using 2,4-DNP solution. When 2,4-DNP solution react with that carbonyl group, yellow orange precipitate will appear. Aldehyde, yes, aldehyde can be distinguished using Fehling solution, Tollens solution or Schiff reagent. In the case of Fehling solution, there is red precipitate. In the case of Tollens reagent, when Tollens reagent or ammonical silver nitrate, that is called Tollens reagent, react with aldehyde, then silver or black precipitate of silver mirror will form. And if shift reagent react with aldehyde, then pink color will uh, restored. So what is Fehling solution? What is the reaction in Fehling solution? Cu plus 2 will get converted into red precipitate of Cu2O. And in the case of silver mirror test, or when Tollens reagent react with aldehyde, then Ag plus gets converted into Ag. Then any of carbonyl compound like aldehyde or ketone which have ketomethyl group means there is C double bond O with CH3. So carbonyl group is present just with methyl group. So that type of aldehyde or ketone when react with I2 and NaOH, that is called haloform reaction or iodoform reaction, they will give yellow precipitate. The aldehyde or ketone which have carbonyl group just adjacent to methyl group, means that is called ketomethyl. Only those type of aldehyde or ketone can give iodoform reaction test positive. But some alcohols, yes, some alcohols can also give iodoform reaction. Which alcohol? The alcohols which can be oxidized in ketomethyl group. For example, ethanol, if we oxidize ethanol, then it will give us ethanal, and in ethanal there is ketomethyl group is present. So ethanol can also give iodoform reaction. So always remember, iodoform reaction can be give positive by aldehyde ketone, plus some alcohols can also give iodoform reaction. Then carboxylic acid, how can you identify the carboxylic acid? By litmus, blue litmus. Blue litmus will turns into red litmus. Then concentrate NaHCO3 solution. You have to remember, concentrate NaHCO3 solution when react with carboxylic acid, effervescence due to production of CO2 will produce. Ester, how can you identify ester? With NaOH. Yes, we can identify ester with NaOH. Then phenolphthalein. So pink color and disappear on heating. It will be disappear on heating. We will get pink color which will disappear on heating with ester. And amide, if we heat the amide with concentrate NaOH, then ammonia will release, and smell of ammonia we can identify amides. Then nitro compounds. Nitro compounds we can identify using Mulliken test. Black precipitate will form. In Mulliken test, nitro compound react with zinc and ammonium chloride. Then Tollens reagent is added, AgNO3 plus NH4OH, and silver will be precipitate out. Amines, yes, amines can be identified by Cl3 and KOH, especially 1 degree amine. If 1 degree amine react with chloroform and KOH, that is called carbylamine test. Offensive smell we will get of isocyanide. So that is also called isocyanide test. That should be 1 degree amine. Only 1 degree amine can give isocyanide test. Then if 1 degree amine react with NaNO2 plus HCl, effervescence of nitrogen we also get. Aryl amine we can test through beta naphthol test. So when react with NaNO2 plus HCl, then beta naphthol, then orange dye we will form. It's very important reaction. You have to remember that is the structure of beta naphthol. And when aryl amine like aniline react with HNO2, then it will form benzene diazonium chloride. Now this benzene diazonium chloride when react with beta naphthol, it will give us that substitution reaction, electrophilic substitution reaction, or it will not give a substitution reaction. Actually it Cl, yes, Cl, and then H of beta naphthol will remove substitute. So in this case we will get orange dye. So we have to remember the structure of orange dye and well as beta naphthol. So that is called beta naphthol. The OH is present at beta position, alpha position, and then beta position of fused ring. So beta naphthol, when beta naphthol react with diazonium chloride, then ortho hydrogen from beta naphthol is substituting. So that is like a electrophilic substitution reaction, and electrophile is benzene diazonium chloride and producing electrophile, and this electrophile actually substitute the H plus from beta naphthol, and orange dye we will get. So that is called azodye test. Important test is that. Then 2-degree amine, 2-degree amine can be actually distinguished 1 degree, 2 degree, 3 degree amine. All amine can be distinguished using Hinsberg test, benzene sulfonyl chloride. If 2-degree amine react with NaNO2 plus H2SO4, red color will form. So that is a Lieberman test. Then in second step we have to phenol. If react with phenol, ninhydrin will form. Carbohydrate, amino acid. Carbohydrate can be distinguished using Molish test, and amino acids can be distinguished using ninhydrin reagent. So that is called ninhydrin test. Inductive effect. We know inductive effect is we can say inductive effect, that is actually we can say weak effect, and that is delocalization of electron, especially of sigma electron. So it is a called transmission effect, and polarization of one bond caused by polarization of adjacent bond. It is a permanent effect, and displacement of electron take place due to difference in electron activity of two atoms involved in the covalent bond. Type of inductive effect we all know, minus I effect, when the group which withdraw the electron cloud is known as minus I effect group, and its effect is called as minus I. So that is a type of electron withdrawing effect through sigma bonds. So this order we have to always remember. That's very important order, and this order of inductive effect we have to remember. That is important order. Plus I effect, that is a when electron which release the electron cloud. So it is a type of electron releasing effect, and order of plus I effect we have to remember. So that is the order of plus I effect. Resonance. Resonance is a phenomena in which two or more structures involving the identical position of atom, means position of atom should not be disturbed. Only delocalization of pi bond as well as delocalization of positive or negative charge lone pair, that may be delocalized, but basic skeleton of the compound should be similar. We can't remove atom in the case of when we are drawing the resonating structure, and resonating structure are actually paper pen based structure. The must condition for a compound to be resonance is the conjugation. Where conjugation is present, then those type of compounds can show resonance. Conjugation means we can understand what is conjugation. Suppose there is a pi bond and there is a group. If this group have positive charge, negative charge, or lone pair, or odd electron, or pi bond, then we can say this group have conjugation with pi bond. So conjugation may be of this type: pi positive charge conjugation, pi lone pair conjugation, pi negative charge conjugation, pi odd electron conjugation, pi conjugation. Suppose if I'm writing like that, CH2 double bond CH and Cl. So here group is actually Cl and there is a pi lone pair conjugation. Suppose I am writing like that, CH2 double bond CH2 positive. So there is pi positive charge conjugation. So type of conjugation is pi conjugation, pi positive charge, pi lone pair conjugation, pi odd electron, pi negative charge conjugation. Again, mesomeric effect of plus m effect. Plus m effect, we all know the order of this group which are showing plus m effect. Plus m effect is again electron releasing effect through resonance. So these groups are showing plus m effect. Minus m effect, it is a basically electron withdrawing effect through resonance. So you have to remember a trick, which group show minus m effect. Any group if key atom is directly connected with a electronegative atom through pi bond, so that type of group will show minus m effect. Now what is key atom? Key atom is the main atom, first atom, which is directly attached to conjugated system. Suppose if we are writing like as N double bond O and O. Now here nitrogen is our key atom and this nitrogen is bonded with oxygen atom through pi bond. So it means our key atom is attached through an electronegative atom using a pi bond. So NO2 group will show minus M effect. Again, suppose if we have C double bond OH. So in this case, carbon is our key atom, which is directly attached to conjugated system of means benzene ring, and this carbon is attached to electronegative atom through pi bond. So it means it is also a minus M effect. It will show minus M effect, means it will withdraw the electron from benzene ring, hence it will deactivate the benzene ring toward electrophilic substitution reaction. Then hyperconjugation. Hyperconjugation means delocalization of sigma electron with p orbital. That is also called no bond resonance. It takes place in alkene, alkyne, carbocation, free radical, benzene nucleus. Hyperconjugation in alkene. Suppose these are pi bond electron and they will shift towards this carbon atom, and here will be this carbon atom will be negatively charged. Then these sigma bond electron will move toward this carbon, so there will be pi bond. So there is no bond is present, there is no bond. So that's why that is called no bond resonance. So actually it can make another two structure, total three structure can be formed, because if this one H make no bond resonance, then these two bond can also make no bond resonance. So that is three structure can be formed. Hyperconjugation in carbocation. Yes, hyperconjugation in carbocation is also possible, like in this way. Hyperconjugation in radical can also possible, just like in this way. Aromatic character, that is Huckel's rule or 4n plus 2 pi rule. The compound which are cyclic in nature as well as have 4n plus 2 pi electron, that pi electron should be delocalized. The value of n may be 0, 1, 2, 3. These type of compounds are called as aromatic compound, and aromatic compound are very stable compound. So these are some examples of aromatic compound. And what is anti-aromatic compound? All conditions are just same, but actually they have 4n pi electron. In aromatic compound there is 4n plus 2 pi electron. In anti-aromatic there pi electron are 4n pi electron. Non-aromatic, any number of pi electron may be there. So if we are talking about stability of these compounds, then aromatic compound are most stable, then non-aromatic and anti-aromatic are the least stable compound. They are the least stable compound. Carbocation. Yes, carbocation is a species in which carbon positive charge is present on carbocation. So they are maybe of sp2 hybridization as well as in sp hybridization carbocation. Carbocation are actually electron deficient species. They have only 6 electrons. So that is some reactions which are showing how carbocation will react. Carbocation can be stabilized by plus I effect, hyperconjugation, minus M effect, delocalization of charge. And this is a general stability order of carbocation, important order. That is the important order. Carbonyl. Carbonyl means if carbon intermediate which in which carbon have negative charge and 3 bond pair, then that is called carbonyl. Hybridization of carbonyl may be sp3, sp2, sp. These are the examples of sp3 carbonyl, sp2, then sp. Stability of carbonyl again depend on these effect, minus I effect, plus M effect, delocalization of charge. And these are actually free radicals. Another intermediate is free radical. Free radical are produced due to homolysis, and free radical actually to be produced there should be high energy. So only in the presence of sunlight, peroxide, high temperature. One more is that electricity, then another peroxide, they can produce free radicals. So it's very reactive species actually. Free radical is a neutral species with odd electron. It is paramagnetic in nature due to odd electron. And no rearrangement is observed generally in free radicals. Carbon atom having odd electron actually always in sp2 hybridized state. So if any reaction is carried out in the presence of sunlight, peroxide at high temperature, homolysis will take place and carbocation will generate. Stability of free radical are like that is 3 degree, 2 degree, then 1 degree. 3 degree free radical are most stable. Then carbene. Carbene are actually divalent carbon intermediates. This is a group of intermediate in which carbon form only 2 bonds. Means carbon is forming only 2 bonds. These are actually neutral divalent carbon species. Most carbene are highly unstable. They are highly unstable and capable of only fleeting the existence. Soon after carbene are formed, they usually react with another molecules. So suppose in this case, and here is also carbene. Carbene actually in there are a lot of reactions in which carbene are formed. For example, in Reimer-Tiemann reaction. In Reimer-Tiemann reaction, dichlorocarbene is formed. Nitrene. Nitrene, the nitrogen analog of carbene, are called as nitrene. They are very much reactive since in them octet of nitrogen is incomplete. And in nitrene only one valency of nitrogen is satisfied. These are the example of some nitrenes. Benzene. Benzene, if benzene ring has an extra pi bond, if it has an extra pi bond, so then that is called benzene, like that. Clearly we can see that newly formed pi bond cannot enter in resonance with other pi orbitals of ring. Since it is in perpendicular plane, it is also important to note that hybridization of each carbon involved in benzenic bond is sp2. Since the overlap between these sp2 hybrid orbital is not so much effective, so this extra pi bond is actually not enter in resonance. Then some points to remember in alkane, then that is called Wood's reaction. 1 degree or 2 degree alkyl halide give the reaction. that is called Wurtz reaction, in which alkyl hydride react with sodium in the presence of ether, and this type of compound you will get. This is not a suitable method for preparation of odd number of carbon alkane. Suppose we are using this one, we will get, that is bicyclo compound. Points to be remembered in alkene and alkyne. The characteristic reaction of alkene and alkyne is actually electrophilic addition reaction. In electrophilic addition reaction, electrophile will attack on alkene. So there is a formation of carbocation. After that, nucleophile can give us product of addition. For example, addition of water. Here electrophile is H plus ion. And Markovnikov addition will be take place. According to Markovnikov addition, the negative charge reagent, the negative part of reagent will be attached on that carbon which have less number of hydrogen atom. Again, hydrogen halide when react with alkyne, then Markovnikov addition first, then HX we have to use in this way. So guys, if you like then please like, share and subscribe the channel. In next class we will study the alkyl halide, carboxylic acid and other chapters we will revise. Thank you.